Hello. So today we get into factoring. You may have done this before. You may have just called this factoring, but factoring takes many forms, and this is factoring one specific basic type of trinomial. So here's what that is. We know that a trinomial is just any polynomial that has three terms, and they can be any three terms. We're going to start by focusing on these things called quadratic trinomials or second degree trinomial. It's called quadratic because it refers to something being squared, quad, squared, and the highest power is this x being squared. So second degree just means a 2 is the biggest exponent you see. Okay, so you may have just called this a quadratic in the past or whatever. So there's all different types of these. We're going to start with the ones, if A is just 1, it's like the most common type that you're used to seeing. And so we have some more vocab. A is called the leading coefficient, and it's important. So everything we're going to see today, the leading coefficient is just going to be 1. So to factor a trinomial, you write it as the product of two first-degree polynomials. So those are little binomials that are like ax plus b, like 2x plus 1 or something. We want to split it apart into two of those, but it's different than any kind of factoring we've done so far. It's almost like a game. There's a strategy to it, but some of it involves a little bit of guessing, which if this is your first time seeing it, you're not really used to guessing in a math class. Strategic guessing, we'll call it. Okay, so this isn't factoring. I just want to get you in the mood. So x plus 6 times x plus 2, you know how to do that. It's called FOIL. Okay, so you FOIL it out. It's x squared plus 2x plus 6x plus 12. And then the middle terms combined, 2x plus 6x is 8x. So the middle terms combine to be an 8. You should be pretty good at that by now. So factoring a trinomial is doing that backwards. We need to be able to look at this, x squared plus 8x plus 12, and know that it splits apart into x plus 6 and x plus 2. And the trick there is, well, you don't see a 6 or a 2 in this, right? So we need to find those two numbers. So here's how. Okay, so here's your first factoring. Factor x squared plus 8x plus 15. So here's the technique. We get this down. At its most basic, you are finding two factors of 15 that sum to 8. Okay, so you kind of go through in your mind and you say, what are the factors of 15? How can we factor 15? It's 1 times 15. That always works. It's also 3 times 5, and that's it. So there's not very many possibilities. So what did I say? They have to sum to 8. Does 3 and 5 sum to 8? Yes, they do. So those are the ones we want. So that's very important. That's the general strategy. We'll see it just gets more complex from here. Obviously, those are 3 and 5. What else could it possibly be? So you can go ahead and list out the different factorizations. Different people do it different ways. I'm not going to do it that way. I'm just going to talk through it. But you need to, forge your own path. So notice that 3 and 5 summing to 8, we could take it. You don't have to do this, but we could take the original thing and say we can split the 8x into 3x plus 5x. So it's x squared plus 3x plus 5x plus 15. Now, if you look back at this, what that tells you is this can then be kind of condensed into something that looks like this. And what are these numbers that go in here? They're 3 and 5. So this can be written as x plus 5 times x plus 3. Now go ahead and FOIL that back out, even if it's in your head. That's going to be x squared plus 3x plus 5x plus 15, which combines into x squared plus 8x plus 15. Okay? So that's what we mean. That's what we mean by factoring a trinomial. And that's what I mean when I say it can be a bit of a guessing game. You have to find those two factors, and you kind of just have to guess them. And the more you do this, the faster you'll get, and they'll just jump out at you. Okay, so do verify it, especially on these first couple. Always go back and check it and make sure that whatever you did works. So every time we do a new example here, it's just going to be a slightly different variation. I'm not really going to repeat myself. And the simplest way is if these are both plus signs. Now we'll look at if this is a negative sign. So it's simpler. So we need two factors of 24. But so it's always finding two factors of c, this last number. those two factors of 4 have to now sum to negative 11. So the only way for that to happen is if both of our factors are negative. So we're not really used to factoring numbers like that, but we can. So just think about, ignore the negative for a moment and think about two factors of 24 that are going to sum to 11. 24 kind of has a lot of factors. So you go through your head and say, is it 1 and 24? No. Is it 2 and 12? No. Is it 3 and 8? Oh, stop. Yes, that was it, right? Is it 6 and 4? No. It's 3 and 8. Okay, so it's 3 and 8. So the more factors a number has, like the harder it is because you have more possibilities. So it's 3 and 8, except you can't use 3 and 8 because this has to be a minus 11. So you have to use negative 3 and negative 8. And really, that's it. So your factorization is just going to be an x minus 8 and an x minus 3. Right, because the minus 8 and the minus 3 multiply to a positive 24. So a minus times a minus is a plus, but the minus 8 and the minus 3 also gives you this negative 11 in the middle. So that's the second possibility. If there's a minus sign here, but c is still positive, you need two negative factors of c. Okay, this is a little more advanced, but not terrible. So now we always need two factors of 36. But now it's negative 36. So it's like we need two factors of negative 36. So the only way to get a negative number by multiplying is to do a negative times a positive, right? If both of our factors were negative, this would be positive 36. So we're always initially looking for two factors of 36. So there's like 1 and 36, 2 and 18, 3 and 12. But in this case, we need one negative factor and one positive factor. So really, the philosophy is this. Now we need two factors of 36 that are actually 5 apart, right? And since one of them is negative and one of them is positive, they're still going to sum to positive 5. But in your mind, when you're looking for these things, you're looking for two factors that are 5 apart. So is it 1 and 36? No. 2 and 18? No. 3 and 12? No. 4 and 9? Wait. Yes. Right? 4 and 9 are 5 apart. So, but we still need one of them to be negative. But we need them to sum to positive 5. So from that, we know that it has to be positive 9 and negative 4. And I'll expound on that a little bit. So that's it. It's plus 9 and minus 4. And then go ahead, FOIL it, whether you do it on your paper, in your head, whatever. It's x squared minus 4x plus 9x. And minus 4 plus 9 is positive 5. All right? And then minus 4 times positive 9 is negative 36. So that's the general rule. Since the middle term here was positive, we look at our two factors and we just say whichever one is larger in absolute value, that one is going to be positive, because that'll bring the sum back up into the positive. If we go minus 4 and then we go plus 9, that'll bring it back up to positive 5. I'll do one in a second where this is actually a negative sign. Okay, so remember absolute value, 9 is bigger than negative 4 in absolute value. So we had the 9 be positive. If we flipped that around, then it would give us a negative 5, and that would be wrong. So it's like the more choices we have to make, kind of the harder it is. Very, very similar to the last one, only this is now a negative 23. So we are looking for two factors of 50 that essentially are 23 apart. Just like the last one, we need one negative and one positive factor of 50. And in your mind, when you're doing this, you still need two factors of 50 that are 23 apart. So maybe it jumps right out at you. That's great. If not, just list them out or just start going through them in your head. Is it 1 and 50? No. Is it 2 and 25? Oh, wait, actually, yeah, it is that, right? So the only difference now is, since 25 has more absolute value, we need this to be negative. You give the negative to the 25 because it's going to be like minus 25 plus 2. That's how you get to your negative 23. Okay, so it has to be that way. So that's it. That's our factoring. That's our reverse FOIL. X minus 25 times x plus 2. Again, please check it to make sure if it worked. Okay, so you see why this is different? It's strategic, but there is also some guesswork. So the way you always know is just look at this middle term. If it's negative, you have to give the bigger and absolute value factor to the negative sign. And I don't want to summarize it all here because your book does all that. So there's only 4 possibilities, and those are it. We just went over them all if the first coefficient is 1. Okay, if A is 1. If not, then it's a whole other ball of stuff. So there's a nice table in your book. Take a picture of that, reference it, whatever. It'll tell you basically if this, then do this. Okay, factor x squared plus 6x plus 10. Looks simple, right? So this is just like the first one we did, which was the simplest one. You're looking for 2 factors of 10 that sum to 6. Okay, think about it. I'll wait. There aren't any. Okay, so this is kind of a trick question. So you can't do it. So you think about it for a minute. Again, I'm not going to try and trick you, but there are plenty of trinomials like this that cannot be factored, at least not by the way we're doing it here. In a little bit more advanced stuff, you actually could technically factor anything you wanted. Okay, but it involves square roots and stuff. Okay, so that's a word for it. It's called prime, and you can kind of see why, even though it's different than a prime number like 5 or 7 or 11, but for the same reason, just because it can't be factored. It has no like factors other than itself. Okay, so if you see that on the homework or the book, whatever, don't think, what, am I crazy? Like, well, how come I can't think of it? Just see maybe it's just prime. A little more advanced. This is the first one we've seen where A is not 1, but never fear. It's going to mostly work out the same way. And also, oh, this isn't even a quadratic, is it? Because the highest power is 3. Okay, so this is a whole other thing. This is called a cubic. Get why? Quadratic, quad, cubic, 3, yes. Okay, but this should ring a bell from the last section. We have 3t cubed, we're using t, it doesn't matter what variable we use, minus 9t squared minus 120t. So what we want to look for when we see something like this is, can we simplify it? And the quickest and really only way here to simplify it is to look for a common factor. In fact, it's to look for the greatest common factor. So look at this thing for a second and think about do these 3 terms have a common factor? They better, or else I haven't told you how to do it. And yeah, they do. So, but you want the greatest common factor. So you can take a 3 out of all 3 terms, and you can also take a t out of all 3 terms. So do that. And always do that. Okay, even once these get a little more complicated and stuff, don't just blindly jump in and start trying to factor. Look for a common factor between all 3 terms. Take it out from. And then don't get rid of it. You can't just divide everything by 3t and act like it was never there. Okay, it has to still be there in your final result. Like this is still factoring. It's just doing a couple different factoring techniques in one problem. So the 3t is taken care of. Now look at the expression in parentheses and factor it. Okay, so the middle term, or I'm sorry, the last term is negative, so you know you need a positive and a negative, but you also need them to be 3 apart from each other. So not too hard. What are 2 factors of 40 that are 3 apart from each other? Yes, I need the Jeopardy music to start playing. They're 8 and 5. And then you just have to say, okay, the middle term has to be negative, though, so I need to give the negative sign to 8, to the one that's bigger, right? So it's got to be a minus 8 and a plus 5. So there it is. So the 3t has to stay in. You cannot drop the 3t. Once we get into actually solving equations using this, we might be able to drop some stuff. But for right now, don't drop anything. It has to still be there. And this is what we call a polynomial that's fully factored. So this is our original thing. We just transformed it. If you multiplied all this stuff back out, you better get this. You will. It's the same exact thing. It's just in a fully factored form. Last one. So this is similar to the previous one. And the thing we haven't seen before is that there's a negative sign on the first term. So it's like it isn't just a 1, but there's a negative sign here. So it's almost like there's a coefficient of -1. In fact, it's exactly like that. So you always want to take that out. You never want to be factoring something where the leading term is negative. It's not that it would be impossible, but it's just, it wouldn't jibe with what we've been doing and the way we've been looking at it. And it's not hard to take it out. So you're going to take a -1 basically out of every single one of these terms. And always do that, okay? And that's not hard. What happens when you do that? All these signs just flip. Verify that that's right. Look at this expression and say, okay, if you were to distribute this negative sign, you'd have -x squared minus 16x minus 64. Look at that. That's exactly what we have. So when the negative comes out of each term, it's just all the signs flip to whatever they aren't. Okay, now focus on what's in the parentheses. You still need to keep the negative sign, and you need to keep everything in parentheses. We need 2 factors of 64 that add to 16. So this one's a little bit different than the ones we've done so far too, even this step. So think about it, 64 has a lot of factors, but you can approach it kind of strategically. Like, it can't be 1 and 64 because that's way too big. So it has to be more kind of in the middle. So think about it, 64 is what, 4 times 16? That doesn't work, but it's also 8 times 8. And that works, right? So this is the first time when the 2 factors that we've gotten have actually been the same factor, because 64 happens to be a perfect square. So it's 8 and 8. They're both 8. So that's fine. It just factors to x plus 8 times x plus 8. There you go, completely factored. So there's a name for that. It's called a perfect square trinomial. We kind of saw that going, the other way. So that's it. That's the answer. There is a little bit more of a concise way to write this. Notice that x plus 8 times x plus 8 is x plus 8 squared. So I would write it that way. I think it's the more concise, the better in mathematics. So I think it's a cute way to write it. So that whole thing factors to negative x plus 8 squared with the negative sign out front. Okay, I wouldn't mark it wrong if you left it like this. But in the future, it's actually going to be helpful to write it like that. So while we're just learning it, yeah, do that. If you get a repeated factor like that, you can just write it as that factor squared.